Hello again, Dr. Schreifels, with our next video on stoichiometry, this one dealing with reactions that occur in solution. So, generally speaking, that's the most common way to do a reaction because it's possible for the reactants to mix and get close to each other so that they can react. So, one way of doing a reaction is something called a titration, where we take a certain amount of one solution and put it into a flask, and then into a burette or some other device where we can measure volume exactly. We add the second solution until we just consumed everything from that first compound that's in the first solution. That we call a titration. So before we get started on how to do titrations and do calculations with titrations, we first have to look at what our toolbox is going to have in it to solve problems having to do with that. So let's write this down, toolbox. And what do we have in our toolbox? So we have, thinking back on things having to do with amount of material and so on, we know that the number of moles can be determined if we know the mass and the molecular weight. So that's one item in our toolbox. That then goes to what we use in reactions. And remember, in reactions, if we have reactants A and B, then the number of moles of B over the number of moles of A that you're going to react must be equal to the ratio of the stoichiometric coefficients in your balanced reaction. So that's lowercase b over A. That's another one in our toolbox. And then finally, the third item that we'll use here, these two we've covered before, the first two. Now for solutions, we recognize that the molarity times the volume is the number of moles. So we're going to use those two. Now in this one, the first one, we are going to recognize that we have both solutions. Well, we know the volume of both solutions. We know the molarity of one of the solutions, so we should be able to figure out the moles. I mean the molarity of the second solution. Excuse me. So how do we do that? Sodium hydroxide is our unknown. So we start by saying, let's call NaOH for base, and this other compound A for the acid. So then we can say that the number of moles of base is over the number of moles of acid will be equal to, they're in solution, so it'll be equal to, remember, going back to our toolbox, so it'll be equal to the molarity of the base times the volume of the base, and then the N sub A will be the molarity of the acid times its volume. And that will be equal to, in this case, the stoichiometric coefficients are 2 for the base and an implied 1 for the acid. That's our fundamental equation that we're going to use. So we want to, our unknown is the molarity of the sodium hydroxide, so that's this quantity here. We algebraically solve that for that. So we have the molarity of the acid times the volume of the acid over the volume of the base times 2. Now we're ready to put numbers in.
So we put our numbers in. There's molarity of the acid is 0.09674, and it's molar times the volume of the acid is 20.97 milliliters. Let's, for the purposes of this problem, convert that to liters, and then we divide by the volume of the base, which was in liters is 0.02918 liters, and then multiply it by 2. The answer then, after doing the arithmetic for that, I believe should be 0.139 molar. So we have figured out the molarity of the base by doing a reaction in which we use the base to neutralize the acid, and how we actually do that part of the experiment is something you'll learn later on, but that's kind of how the result of that titration is what we end up with. Okay, so now we're ready to do the second one. The second one's a little different because we're starting out with a mass of the acid in this reaction and not molarity or volume. So our equation is a little bit different. The top part's going to be exactly the same, molarity. Oops, let's go back to black. Molarity of the base times volume of the base equals the mass of the acid divided by the molecular weight of the acid equals the ratio of the stoich. So the top part of this is the moles of base. The bottom part is the moles of acid. So that ratio will be equal to the ratio of the stoichiometric coefficients. There's a 1 for the calcium base and 1 for the oxalic acid. So that's 1 over 1. And then we do some algebra to get to what we want to finally use. So we have molarity of the base equals the mass of the acid over the molecular weight of the acid divided by 1 over the volume of the base. And we had the ratio of the stoichiometric coefficients, but that was 1. So now we're ready to put numbers in. We have 0.7568 grams divided by the molecular weight, which is given, 126.07 grams per mole. And then the volume of the base is, in liters, is 0.03162. You can see that if you follow the units that you're going to end up with moles per liter, which is, of course, is what we expect. And the molarity of this of the base in this case ends up being 0.189. And that's how we deal with determining molarities from a knowledge of the solution characteristics, both from mass and molarity of the other solution. Hope that was helpful in clarifying how to deal with reactions and solutions. Have a good day.